So, well, let me first introduce Juanjo Hierro, Chief Technology Officer at the FIWARE Foundation, also Chairman of the FIWARE Technical Steering Committee, which is the governance body within the FIWARE open source community that drives technical direction of the FIWARE platform and FIWARE technologies. And this presentation today will elaborate on common concepts and technologies which will enable to define common reference architecture, since, as Angela was explaining, one of the goals of Open Day is that of trying to determine what could be common across domains regarding definition of reference architectures. And since we intend to bring support with these architectures to development of smart solutions in different sectors, perhaps we have to first start with a question, is there a common architectural pattern we can talk about when we think about smart solutions? Well, we believe there is actually an architectural pattern. And that is the fact that all of them are about gathering data from many different sources, including but not limited to Internet of Things, to build a digital twin representation of the real world. That digital twin representation, also referred as context representation, is what is constantly analyzed and processed in order to simulate or automate certain processes and bring support to smart decisions. And this is a common pattern for any kind of a smart solution you think about in the different domains, gravitating around this vision of managing data and creating a continuous feedback loop around that data. What is a digital twin, and how or what kind of aspects we need to establish to determine a common view of representing digital twin and managing this concept in the different architectures? Well, a digital twin is a digital representation of an asset characterized by attributes. And here we have to distinguish between properties describing the state, but also the relationships with other twins, and connected to the notion of linked data, attributes whose values change over time, some of them more dynamically than allocation requirement in all cases. What is context in such a vision is, well, as simple as a collection of digital twins I'm managing in my applications. And what is essential if we want to define a reference architecture would be the standard API for getting access to info about digital twins. A standard API that should support concepts such as, of course, simple and complex queries, but also geo-queries, temporal operations, because digital twins have a history I want to process, the ability to subscribe and get notifications about change on digital twins, and also the ability to get results, responses, and notifications in different data formats. If we think about manufacturing, the notion of digital twin corresponds to asset administrative shell. If we rely on this concept of digital twin, actually this vision is common across domains. It works for cities. Here the entities might be the shops, the citizens, the buses. They might be also digital objects like the claims that citizens may trigger. Same in agri-food. The difference is that we may deal with different entities and attributes, but all is based on common concept. Manufacturing, we may think about transport robots, shop floor, the palletizer machines, operators, and the context of a factory. Same in energy, where we are talking about different twins around the storage elements, a wind turbine in a wind power plant, a substation, elements like that. There will be some of these entities that might be common, by the way, because they are concepts that are common across domain. If I'm talking about the weather and aspects like weather forecast, this is a concept that might be common and needed in different domains, energy and cities, or energy and agri-food, because it's relevant in both cases to manage data about weather. Well, we talk about a standard API as something that is required. What in FIWARE community, but also in this vision within OpenDay, we really believe that one of the interesting assets to rely on is the NGSI-LD API. This has been standardized by ETSI, multiple open source implementations available and through the FIWARE catalog, and supported by the FIWARE community, and supporting all these functionalities that I mentioned before are going to be key. The notion of a context broker as a core component in the architecture of the systems, supporting and implementing this standard API is what can build the basis for creating reference architectures that are common across domains. Context broker is essentially a server associated to a transport endpoint where queries and requests on the NGSI-LD API are being served. And with this, what categories of reference architecture we may consider? We may consider architectures for vertical smart solutions. So as an example, what would be a smart welding solution for a factory, or a smart watering solution in a farm. But also we have to think about reference architectures for smart organizations. So covering the needs of whole of organizations as a whole. Here is where we can talk about smart cities, about smart farms, smart factories, or smart grids, if we are talking about energy, or smart hospitals in health. So let me elaborate a bit on, but going quickly on the how these reference architectures may look like gravitating around this notion of digital twin and the NGSI-LD API. If we talk about vertical smart solutions for cities, but same happens with farms, we have an architecture that might be structured typically in layers. A first layer dealing with data acquisition to gather data coming from different sources, IoT, robotic systems, third systems, information systems, to create this digital twin representation of what is going on that is relevant for that particular solution. Here in this picture, we are representing a smart watering vertical application, and getting all this information together and creating this digital twin representation, we are able to put on top of that layer for supporting data processing, analyzing, simulating, visualizing different aspects, and this way supporting the different functionality. This is actually an architecture pattern that applies to different domains. If we go to and think about smart warehouse transport robotics system, we have essentially the same elements. Simply, we are talking about different models, different twins, perhaps different protocols that in IoT protocols we have to adapt and be using, because in a factory, typically I will be using OPC UA as compared to MQTT, which probably, or LoRaWAN, which probably is the most common case in smart farming. But other than that, essentially being able to follow a similar pattern. Same for energy. And well, this is just a way to represent exactly the same reference architecture, but turned 90 degrees clockwise. So the data flow can be illustrated from left to right, from the gathering of data from different devices and systems, creating this common digital twin representation that is accessible through the context broker technology and using NGSI-LD and being able to process. Second category of reference architecture would be for smart organizations. Here we talk about managing the information and being able to support smart decisions at global level, and an architecture is similar. So here the difference is we are integrating information coming from different vertical solutions in what we typically refer as a system of systems approach, but again generating a digital twin representation of the global organization. It might be the city, it might be the farm. If we are talking about agri-food sector, it could be a factory, it could be a smart grid. Elements that are here new compared to the reference architecture I mentioned before, and I wanted to highlight is, first of all, the way to integrate with blockchain technology and distributed ledger technologies. We talk about digital twins. We talk about context that is constantly changing over time. And these updates on the state of digital twins can be modeled as the transactions that I may wish to store on the distributed ledger. And this will provide a basis for actually perform auditing, logging of transactions, and be able to, guarantee in a trustworthy manner that the transparency of processes and also the ability to certify those processes. In that sense, this vision of digital twin and the usage of NGSI-LD really complements very well with distributed ledger technologies, because we bring to the ledger technology something that this doesn't solve in itself, which is how you guarantee that the data that you are storing on the ledger is actually accurate. Here, the idea is by means of automating the capture of data from the sensor layers through adapters into this context broker, and then automating the transaction of and the recording of certain transactions. Don't need to be all, but certain transactions in the ledger. We are able to deliver a promise, which is that the data that we store in the blockchain is really good data. Second aspect to illustrate is how you may decide as an organization to export part of the data to third parties using publication platforms, and also bringing components that support the monetization of part of the data. And this way, organizations being able to get engaged into a data economy, sharing data, being able to monetize that data, and also as elements in this formula, the ability to incorporate IDS technologies to make sure that the sharing of this data and publishing could be based on trust. Conclusions to finalize this presentation, and of course I'm happy to answer any questions and get contacted later on to elaborate further on any of these ideas. Is, well, how to materialize the concept of digital twin. This could be essential to create reference architectures that can work for different domains. And here the notion is we need to come with a simple model that is intuitive, and this is the idea that gravitates around entities representing real digital world objects characterized by attributes, the need for a standard API, to manage access to information about digital twins and also being able to alter the state of digital twins. This is what NGSI-LD may provide. And this interesting aspect is gravitating around the digital twin concept. We can really be able to integrate multiple technologies in a common reference architecture. On one side, we are integrating data from different systems and IoT devices, robotic systems, information systems, and creating a common representation for all the data coming from all these disparate sources. On the other hand, we can, and I elaborated, so I will not insist, part of the transactions on digital twin can be stored on the distributed ledger, and this can provide a means for trustworthy accounting, transparency, and be able to perform forensics on process in order to certify certain processes. Very important, and I didn't mention before, but I want to emphasize now, digital twin info is the raw material over which processing takes place. This can be in the mode of artificial intelligence algorithms, where on top of which analysis can be also performed. Here is where we can use and integrate big data technologies, or we can also visualize and simulate systems. Last but not least, digital twin information, the exchange for data, how and trade, bringing support to materialization of the data economy. Digital twin data access and usage control is required in all cases and should be part of the reference architecture we can build. We have explained that these architectures gravitating around the notion of digital twin and context information management can be applied to both vertical smart solutions and whole organizations following a system of systems approach. This system of systems approach in organizations allow to support a number of properties that are really relevant for the economy of systems and the sustainability of an ecosystem around the architectures we define. And last but not least, ingredients for the trusted exchange of data among organizations can really be based on one side, IDS connector technology, which would provide the kind of security framework that might be needed, and on the other hand, what would be the kind of exchange among organizations, which would be the information about digital twin exchange through a standard API, which is NGSI-LD, and leveraging on standard-based data models. That is all, and I think could provide hopefully a good basis for discussion and the work towards creating a common reference architecture. Thank you.